Hey everyone. Up first for our lightning talk is Sameach Block.
Hi, I'm Sumaya, and this is my dad. Today I'm going to talk to you about JewelBots. JewelBots is a programmable friendship bracelet that's also smart, and it's aimed at girls in their preteens and teens. One of the two awesome things about JewelBots is one, they're programmable, and two, they also have a friendship quality so that you can talk with other JewelBots via Bluetooth. Next. So it's programmable. JewelBots uses Arduino IDE, as I said before. So here's an image of an empty sketch. And Arduino IDE is a free service for developers, so they can program using C++, I believe, at least for JewelBots, so that they can program devices. This is a picture of the first code that I ever wrote. And here I used LEDs to turn on lights and turn them off. So these are the four components in your program. You have your LEDs, your timers, your buzzers, and your buttons. So the LEDs are the colored lights. The timers, you can put a timer in between your code. The buzzers, the JewelBot is a haptic device, and so the JewelBot can buzz. And then there's a button. So you could write it so that instead of turning on your code, turning on the JewelBot to do your code, you actually turn on the button. So how can you use these components? There is a Pomodoro timer. This is a code I wrote. And as you can see, I pointed to some of the components that I was talking about earlier that are in my code. And here's a video, actually. So a Pomodoro timer I use to focus in my homework and really for anything. So this is a shortened version of it, but a Pomodoro timer is like, it goes for 30 minutes on the JewelBot, and it flashes green every 30 seconds. And then when the timer's up, I know, okay, so I can go take a break. And then I go back and do more homework. I love JewelBots because it's really just a great way to learn about code when you're a beginner, such as myself. But then you also, as you advance, you can write more complicated code with the JewelBot. I also love it because it just has a really great community. So what I'm saying by this is JewelBots has a community forums. When you buy a JewelBot, you're not just buying a JewelBot. You're becoming a part of this community of young girls and others who are beginning to learn to code or know how to code. And it's really awesome because I've actually got to make friends. Sarah, who's the CEO, she had a Google Hangouts, and we all got to program a game together. I also love it because I get to code with my dad. So my dad really taught me about JewelBots, and what we like to do is we learn about it, and then we write some code here, and then we wear it. This is us at the Dr. Holiday convention in Seattle, and so we wore our JewelBots, which were flashing blue and white colors, because that's the theme of the show. So where should you go now that you know all this awesome stuff about JewelBots? As I was talking, there's the community forums where you can post code, share code, meet some friends, show videos of your JewelBot, and it's really a fun experience, and I just love it. And then along with that, there's also a zine that you can use, and it has like a bunch of they do interviews, talk about the JewelBot, cool things going on in Steam, and this is, you probably can't see it, but this is what the zine looks like, which is really great. There's also my blog, Bits of Code and Imagination, where I write about my experiences learning code, write tutorials, and write just about code and also writing. This is the learning blog where I learned how to code JewelBots, so that's also a really great source. I hope that with what you've learned today, you will tell others about JewelBots, maybe even get one yourself, and really just #code like a girl.
Wow. That makes me remember, what was I doing when I was 12? All right, next we have Daniel Plainstead.
Okay, good afternoon. Hello. So I'm Daniel, and I'm going to talk about some software that I wrote and about handbells. These are handbells. This type of handbells, a set of them has maybe 60, covering 5 octaves, and those cost, tens of thousands of dollars for a set. These are also handbells. This is C sharp. This is F sharp. So you've got a set of these handbells, 2 octaves, 25 notes, and you can get that for about $150. So that's a lot cheaper. How did I get into these? Well, this is my mom in the middle there, and she works with a bunch of different groups of kids. She works at a school, she has a youth group, she teaches at our church, and with all of these different groups, a lot of the times she'll have them play handbells. Well, how do they do that? How do they know what notes to play? In the front there, you see that there's these stands and these boards on the stand. These are actually foam boards, and she does this with them. So she puts the music on there. It's color-coded according to the bells. So each note has a different color, and that corresponds with the color she put on there. And then when they play a song, usually there's an accompaniment piece of music. And so the background music will play, and then she'll work as the conductor. And she'll point to each note when it needs to be played. So when you have a bell, when she points to your color, you ring that bell. Well, eventually we got bells for our family, but I didn't want to go to all the work of doing this. And so I was thinking, what can we do? And I realized this is a problem that's been solved. I've played Rock Band, I've played Guitar Hero, and they kind of have the concept of notes moving across the screen, and when it gets to a certain place, you play it. So that's what I've done. I call this Handbell Hero, and it's kind of basically the same thing. The notes move across the screen. When they get to that line on the right, you ring your bell. So these are some kids from our church in a Christmas program, and over here you can see what they're looking at as they play. So, and I don't restrict myself to kids. If I can get adults to play, I'll have them play too. So this is what these people sounded like. So that's Handbell Hero. I've had a ton of fun. I just think this is great. Guitar Hero and Rock Band were really successful because they let pretty much anyone have the experience of playing music. And with this, anyone can actually play music. So I just love it. And software can do amazing things. And in many cases, it doesn't need to be impressive on a technical level to do so. This is a Windows Forms app with the screen is drawn on the paint method, and that's 15-year-old technology. But it's been super fun for me, and it's grown way beyond what I would have expected. So I think all of you can do amazing things too. If you have an idea, if you think, hey, maybe I can solve this problem in this way, give it a try, and you never know what will happen with it. If this looks fun to you, if there's people interested, then after 5, we'll get together, and if you want to play handbells, we can try doing that. Thanks.
You got that clicker? Oh, cool.
All right, thanks. I'll give you a second. Yeah. I'll stall. Now, I wish I had that when I was in high school. When I was in the 9th grade, I had to take music, so we had a voice, so we actually had to sing. and I can't sing. I know, not most people are not really tone deaf, but they haven't heard me try to sing. So it was so bad, I had to be put on the tambourine. Like said the night went to the little lamb, bum, 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 bum. Do you hear? So I wish we had, that for me back then. So up next, we good? All right. Up next is James Montemagno.
All right, thanks. Hey everyone, I'm James. I'm super excited to be here for a lightning talk and totally tell you about this awesome project that I had absolutely nothing to do with, because for years I've been telling people how amazing C# and .NET is. Combined with .NET Core and Xamarin, literally you can put .NET absolutely everywhere, which is amazing. I can target every single platform, and I've been doing so for the last 6 years. If I want to go to iOS, Android, all the new stuff that just happened at WWDC this morning, I can totally do it all in C# and share all my code everywhere. But I talk to developers all over the world, and the problem is, what if you're a developer that is stuck writing Objective-C and Java and lowercasing things for no good reason? Well, you're like, man, what if I could just use .NET absolutely everywhere? And all of those amazing NuGet libraries that were out there, I didn't have to give up that addiction of going in and just searching for James Montemagno and installing all of my NuGets. That's what I do. So do I have to start from scratch? Do I have to switch industries? What do I do? Do I reevaluate my entire life choice of becoming a .NET developer or doing Objective-C or Java? Or heck, maybe you join a new company and you're forced to write Objective-C and Java to do iOS and Android. Well, no more, because now we have the Embedded Ater 4000, the best project ever. What this enables you to do is take your shared C# and .NET logic, run it through the Embedded Ater 4000, and create native libraries for each platform. Whether you're targeting Android, Mac, iOS, tvOS, or even Linux, your .NET code can live everywhere. Let me show you what that looks like. You go to the Embedded Ater 4000 GitHub repo, and you install a little package on your Mac machine. I'm creating a weather application. I'm going to start here on Mac OS. As you can see, I'm a beautiful graphics designer. Now what I have here is a .NET project in Visual Studio for Mac. I have a shared project, iOS, and .NET. Here's a normal class with some temperatures, using some getters and setters. And here I'm going to use the Yahoo API to simply create a constructor, use my familiar web client, parse some JSON values, and boom, even handle exceptions with awesome C# 6 and 7. Now to get through the Embedded Ater, all I'm going to do is run a simple Embedded Ater command right here. So whenever I compile it, it just re-outputs some files. I'm just going to go ahead and build it. And based on the project, whether it's iOS or .NET, it'll output a few different things. So for the Mac application, it'll put out a dynamic library. And for iOS, it's going to go ahead and put out a framework that's going to be in there. So here it goes ahead and it compiles it all up. And what's beautiful here is in the output, we give you beautiful, stunning header files, and of course, a dynamic library. So I've added them here into the Mac application. There's those beautiful bindings that I was talking about. Look at that Objective-C. So good. Said nobody. Ever. So now what's great is now I can go into my actual Objective-C code and call into the .NET code that I just created in Visual Studio for Mac. Here I'm just going to go ahead and start up this application. I'm just running it from Xcode's, everyone's not favorite IDE. And now I can go ahead and search for Seattle. And this was this morning. Sunny. That's the first time in a long time. So now what's awesome is that I have this exact same code running in Mac OS, and I want to bring it into iOS. Why wouldn't I want to do that? So I'm going to go ahead and open up a project here for iOS. And what I'm going to do here is show you that I have the framework that is generated at that build time. We saw two things happening. It's all packaged up, so all I need to do now is go into that header file, and it's literally basically the same code, but interacting with the storyboard from iOS. I go ahead and build it up here, and here's my iOS simulator running. There we go. Now I'm going to search for my hometown, little Cleveland, Ohio. It's probably miserable, naturally. So now what's great here is that I've run the same exact code from .NET on Mac and iOS, but it gets better. Because what if I want to come in and create native, it's Xamarin, right? So I have access to every single API. So here I have a weather view where I'm going to tap into core location, but all in C#, using powerful C# features like async await, lambdas, events, and delegates, things because we're not animals and we love our programming language. So this will go through, and instead of the actual app doing any work, I'm going to come in and replace the entire user interface in a super ugly hack where I review all the subviews and add that subview manually, which is awesome. So now we're going to see a whole new user interface, all written in C# with all of our proper language features. So here we go. It runs up again. So I can do a few things here. Since I've added into the actual logic, I can still search for Seattle and get the location or get the weather, or say get location and tap into the native APIs all in C#. What's great here is I can take this and now also run it in any .NET application. It's not limited to just iOS, Android. I can now create a jar binding or an AAR and bring it anywhere. So with that, with the Embeddinator, .NET truly now goes to every single program written in any single language, and that's it. Go. And it's all open source on GitHub.
Thank you, James, for not invoking any memories of my childhood that I have to share now, since it seems to be a pattern. Are you set up? Okay, I was going to tell a joke to save time, so you. No, I'll save it for a rainy day. All right, next up is. Does someone go aw? Luke Faust.
All right. So about a year ago this week, actually, I was finishing up one of my favorite projects I've ever worked on. So many of you may know next week is E3, which is a big video game where the companies, they like to announce their new products. So I was working on a project for Xbox called Xbox Design Labs. I don't know if anyone's heard of it. If you have, or if you haven't, it allows you to build your own custom Xbox One controller. You get to pick the colors. They build it for you. So this project had some interesting requirements, which is it's super secret. No one can know about this. But the moment that they announce it on stage, they want everyone to know about it. And we had an interesting problem, which is our deployments were not fast. It's not like we could say, Phil Spencer can get on stage at E3 and say, Xbox Design Lab, and then we click deploy, and then 3 hours later, people can access it. So this wasn't the only situation we were trying to solve this for. We had a lot of things during development. We couldn't wait for deployments all the time. And so I'm going to share with you today how we solved this problem. It's not an amazing thing, but it really saved us a lot of time, and I use it on other projects as well. So the idea here was just let's separate our deployment and our configuration, and let's allow us to deploy or update our configuration somehow outside of deployment. So recently, with .NET Core and its configuration libraries, it actually has a nice in for this. When you add a configuration file to .NET Core, say a JSON file or whatever, you have this flag, which is reload on change. And I kind of asked myself, that sounds great, right? It creates some kind of file system watcher. It watches your file. You update it. Your configuration's upgraded. It sounds magical. But I wasn't quite clear on who's going onto their servers and updating their configuration. So I don't really know, what are we watching on the production? This is a good development feature. But then I started to think, well, what if, we just spin off a background thread, watch the configurations, which are somebody else in your own service on blob storage, whatever. And this is kind of where this idea grew. So we use this feature for a couple of interesting scenarios. So I currently work on MSN.com. Every feature we ship on MSN.com is shipped behind a flag, so you can say, turn this off, turn this on, for reasons of, shipping something out of order, but also, let's say we have some sort of live site issue, we need to turn something off. This can all be done remotely through these, remote configuration background thread. If you're interested in I'm not going to get into the implementation detail of how we do this, but this is the idea, right? .NET Core doesn't care where the configuration comes from. It's just that it can be updated on the fly, and now you get the latest version of everything. So just real quick, a couple of gotchas that we ran into that you maybe have to think about with such a scenario. So when this configuration gets changed remotely, you detect the change, great, and now you have the updated thing on, on whatever server this is. But that doesn't help you if somebody's holding on to a static copy of your configuration, right? You can update it and they're still holding on to the old copy. So you have to really think through the lifetimes of the configuration objects in your application. Singletons and statics are probably not going to serve you very well, which brings me to the second gotcha that we ran into actually recently, is you don't want to do too much work on every request. When somebody says, give me such and such configuration, you don't want to have to go and, .NET Core has this whole process of binding your configuration to some kind of hydrated object, which is not, and understandably so, not such a performance thing. So you have to be really careful with how much, caching these things and how much work you're doing on each request. But in the end, this has saved us, like I said, a ton of time in development, in production, live site, all across the board. And now, multiple projects I've used this similar idea, and I keep iterating on it. And if you want more details, come talk to me, and I'll talk to you more about it. Thanks.
Okay, so we're paging Alistair Chapman, if you're around. Oh yeah, can you come to the backstage area? Yeah. Okay, so this is my favorite joke ever. And you have to understand, I'm from New Orleans, so I have a bit of an accent. Thank you. Who dat? All right. A piece of string walks into a bar and says, bartender, give me a drink. And the bartender says, we don't serve strings in here. So the string goes outside. He's all mad. String ties himself into a knot and then kind of frays the edges. And he walks back into the string walks back into the bar and says, bartender, give me a drink. And he goes, you're that string again. And he goes, no, I'm afraid not. Thank you, I'm here all week. All right, next up is Lena Hall.
So I'm going to show you how to prototype a distributed snapshot algorithm in F#. So we can use snapshot algorithms for checkpointing system, for future recovery, for deadlock detection, termination detection, ensuring consistency of the system. And there are many approaches on how to perform snapshots. For example, some of them are based on marker messages, some of them use clock. And I'll show you how to actually prototype it in F#. So in general, prototyping is helpful when you need to implement some algorithm in context of existing distributed system, or when you're just trying to understand an unfamiliar distributed algorithm in general. And I've chosen F# for prototyping because it's a great OSS language and it's functional. So it should be intuitive for people who don't know F#. So anyway, the algorithm is called Chandy-Lamport snapshot. And it's based on assumption that there is a cluster of nodes where all of them are available and they can talk to each other and reach each other. Nodes exchange basic messages, which are just usual messages your services are sending to each other. And nodes can also send out marker messages or snapshot messages, which are special types of messages for taking a snapshot. And any node can initiate a snapshot at any moment. So imagine a system where the state is amount of money in a person's bank account, and anyone can send money to each other if there is enough money to send. So accordingly, the state of channels is messages with money in transit between nodes. And marker messages are just for performing the snapshot, so they're not captured as a channel state. So the foundation of everything is a snapshot node type, which is based on abstraction of a networking node, which is just an asynchronous TCP server. And as you see, there are some basic data types like contents, basic message, channel state, neighbor, and so on. Any node can say basic messages to any other node that it has channel to. So here's a send basic message function that takes the content, that basically checks if there is enough money to send, prepares the message, and sends it out to neighbors. Any node can initiate a snapshot, which that means that it persists its local state and sends out a special type of a message, like a marker message, to its neighbors. That means any node can receive a marker message at any point in time if there is a snapshot going on. And when a node receives a marker message for the first time, it persists its local state and the state of the channel it received this marker through. So if it's the first marker that a node receives, this channel state is empty because this algorithm assumes the first in, first out ordering of channels. When the node receives a marker from some other node after it has done a state snapshot, it means that some time has elapsed from the moment it captured its local state until the moment it received another marker. So there is a definite possibility that there are some other basic messages that came through during this time. And these messages, they can't be captured as a part of channel state. They should be captured as a, one second. They should be captured as a, they should be captured as a part of the channel state because they can be captured as a part of node state of either sender or receiver because they both have already captured their state. And here is basically, if we spool up 3 nodes using the Chandler-Lamport snapshot, let's say they add each other as neighbors and decide to send some money to each other. Like, let's say the first node sends money to the second node and the second to the third node. And we start a snapshot by the first node. And you see that there is a channel state captured and node state captured. There is another thing you can do to make sure that you got your algorithm right. For example, this is a part of TLA plus specifications. If you're trying to enforce some of the distributed system properties like consistency or liveness, so this is another thing that's very interesting if you have time to look at it. But it's another whole topic. So thank you, and reach out if you have any questions about this.
All right, Scott Blomquist. Yeah, there, okay, that was easy. I so badly want to tell the story about the last time I ever said the words best practices. I think it was like 10 years ago, and for some reason I'm starting to remember something that someone told me once about saying that word, and for some reason it has been stricken from my vernacular. I have not been able to say best practices without like cringing, like what did I just say? Anyways, are you ready? You're thinking good, okay, I know, right? All right, so up next is Ted Newitt.
All right, so they asked me to do a lightning talk on Monday, and I said, sure, I'm happy to do a lightning talk. What do you want me to do? And they said, well, you've got this session that we see on your list, Introduction to .NET Bytecode, CIL. And I said, okay, and how long is a lightning talk? And they said, 5 minutes. I can't even finish the prologue to the ECMA specification in 5 minutes. You want me to go over the entirety of that specification in 5 minutes? They said, no, because if you actually do the full talk, we're worried you're going to make everybody's brain melt. I'm like, oh, okay, all right, fine. So what I'm going to do is I'm just going to introduce you to the concepts of and trust that those of you who are interested will go pursue it further. Now, most of us know what this is, right? I mean, granted, the F-sharpers in the room, they won't be able to recognize this, right? But the rest of us, we know what that is, right? The question is, what does that turn into? Remember, IL is the intermediate bytecode representation that the CLR actually executes. Well, to be fair, they don't execute it, they do a just-in-time compile, but then Mono goes ahead and execute. Okay, we'll just say it executes, right? And there's all kinds of interesting things about bytecode, but the most relevant issue that most .NET developers need to face is the fact that bytecode is what your source code turns into. So if you ever looked at the yield return statement and wondered, how exactly does that work? How many of you know how it works? Show of hands. Yeah, like 3 or 4, maybe 5 hands, right? The rest of you are like, oh, no, I just use it. It's just there. I mean, why? Okay, so is this actually a better or worse performance curve than, for example, working with a collection or something similar? You won't know unless you can drill one level below the level at which you're at. And IL is actually one of the simplest assembly language you'll ever see in your life. So I'm just going to do a Control-Shift-B here to print up my little hello world thing here. And then over here, we're going to fire up a utility, comes free, out of the box, with every installation of Visual Studio called ILDASM. Okay? And unfortunately, ILDASM has forgotten my font settings. So view, set fonts, tree view, and we'll kick this sucker up to, say, 24. And what we're looking at is the assembly in its sort of native tree structure. What we see, first of all, is hello world.exe up there at the top. The assembly, every assembly always comes with the manifest. You can drill into that and look at some of your declarations, for example, the module name, et cetera, et cetera. We can also see hello world there with this little interstate shield symbol next to it. That's actually the namespace declaration. Then we can see inside of it one node, hello world.program. Well, that's the full formal name of the hello world thing that I just built. And you can see .class private auto ANSI before field in it. We can see .ctour, that's the special name for the constructor. We can see main down here. And main, looking back at Visual Studio here for a second, it's pretty boring, right? So let's go look at the bytecode that makes that thing up. Whoops, and again, ILDASM, not remembering fonts, making me grumpy. 24. You gonna be able to do that there, ILDASM? Yeah. All right. So what we see here is initially what looks like gobbledygook, right? Because most assembly languages, unless you know how to read them, look like gobbledygook. But here we see dot method. That indicates that this is a method as opposed to a field or a property of some other form. We can see static void main. We can see a bunch of things that we recognize from C# because the C# language is actually a pretty faithful representation of what we see in the ECMA specification. We can see dot entry point. That's a directive that says specifically this is the entry point to this assembly. This is where we begin. It has nothing to do with the name main. Main is only important to C#. C# puts that directive in. And if you wanted to program in IL assembler, by the way, we can dump this out to a text file, modify it if you'd like, or if you really want to prove your programming chops, you can write IL assembler by hand. That's if you really have something to prove to your coworkers, all right? But notice that here we can see a bunch of local references here. Actually, that looks different than what I had in my... This is the Hello World application, right? Well, all right. Doesn't matter too much because what we're looking at here, this is actually some sample code that I cut down, but I guess for whatever reason it didn't get saved. So we can see, first of all, the first instruction is a no-op. That means the same thing in every assembly language. You can see load stir, hello world. The IL environment actually has an understanding of objects. So what it's doing here is it's pushing a reference to that constant string onto the execution stack. Everything works off of an execution stack. Operations like load stir push things onto the stack. Operations like call will pop things off of the stack. We can see call virt, that invokes a virtual method. The try block here says we are actually going to set up an exception handler. We can see some references down here at the bottom. You can see the end of the method, et cetera, et cetera, et cetera. And I told you I wasn't going to be able to teach you all of IL in 5 minutes. That's all I got for right now. But all you have to do is 2 things in order to start studying all of what I've just shown you. Number 1, you got to download the ECMA specification. That is the official reference on IL. Number 2, fire up ILDASM, look at some code that you've written, look at the generated output, work through the execution stack. Everything else is just details. Peace.
Thanks, Ted. A 3-legged dog walks into a bar and says, "I'm looking for the man who shot my paw." And on that note, next up is Alistair Chapman.
All right. Afternoon, everyone. Can everyone hear me? Yep. Excellent. Okay, so apologies, it's a bit rough. This is extremely short notice, this talk, but I'm here today to talk about cake. Now, what is cake in a nutshell? Cake's a delicious dessert baked, wrong cake, C# make. Cake is a build tool designed for C#, written in C#, and designed particularly for C# and .NET projects. You can build anything you want in it, and we support any language. We'll just judge you quietly if you come into the conversation asking about Java. Now, Cake is a DSL based on C#. It's actually a superset of C#. So a script for Cake looks like C#, but with some extra things in it. It's fully cross-platform, so it runs on Windows, Linux, and Mac OS. It's built for every CI system under the sun, and it's designed to be very, very simple to get going out of the box. We include Visual Studio extension, we have VS Code support, there's a Yeoman generator, there's anything you need to get started, and it's all obviously fully open source. We have a thriving community around Cake itself with over 150 community add-ins at this point. I believe, in fact, it's 151. We're happy to provide support on Gitter and through GitHub, obviously. And realistically, there's add-ins available today for basically anything you would need. So this is what a script looks like. Obviously, it may look a little bit different to your average C# because it is, as mentioned, a superset of it. But that does mean you can use anything you can do in C#, you can do in a Cake script. So here you have the target up the top. We have a setup that gets run before anything else, teardown gets run afterwards, and a task down here that does the incredibly helpful thing of saying hello, Cake. And that final run target is the one that actually glues it all together. But that doesn't really tell you what you can do with Cake. What you can do with Cake is basically anything you want. This is Cake itself being built by itself. So when we do a release for Cake, that's all done using a Cake script. It's very large, it's very complicated, but these are all the things we do out of the box. So we've got full versioning support, we're restoring packages, we're building things, we're running unit tests, that's pretty simple stuff. We're also copying files around, producing zip packages, creating NuGet packages, creating the Chocolatey packages for Windows installers. We create the homebrew packages for the Mac OS people. We upload them to Appveyor, upload our coverage report, publish to MyGet and NuGet in the same step, as well as publish to Chocolatey, Homebrew, and to GitHub in one big hit. All of that gets run out of one C# build script. But that's not particularly helpful. Let's have a look at a quick demo. So if we run here, it's a bit tricky with one hand. I'm going to use the Yeoman generator because it's nice and easy. Accept all the defaults, and this is what you get. Oops, sorry, hang on, there we go. And you get a couple of bootstrappers and a Cake file. The Cake file itself is pretty simple. It's the one we saw before. Now all I need to do is run build sh. This is on Linux, obviously, so it may look a little bit different on Windows. That's all it takes to get started. You can add anything you need to the script. You can take advantage of our VS Code support, open it up, make any changes you want, and then run again to quickly build your project. We do include support for a whole, as I mentioned, a whole series of CI providers. Ooh, it's a bit fuzzy. Let's make that a bit bigger. Whoa, that's a bit better. We do include support for a whole series of CI providers. Last time I checked, that included Appveyor, MyGet, Continuous CI, GoCD, TFS, VSTS, I think I mentioned GoCD, Travis, Bitbucket Pipelines, and a few others out of the box. Obviously, you can run it anywhere. You can run a PowerShell script, a Bash script, or you can install Cake on, which, as I mentioned before, is all of Windows, Mac OS, and Linux. So how do you get started? We have our website, which includes all the details of how to write scripts themselves, including all the supported tools you can see down the left here. We have all of our community add-ins, of which we now have a lot, provided by our awesome community in a lot of cases. So you can use any of these in your scripts very simply with a simple preprocessor directive, which I won't go into because we are running out of time. You can also jump on our Gitter room. There's generally always someone there ready to help, and you can find the source for the whole project on GitHub. It's all provided there. If you do need a hand or you want to know more about Cake, come find me afterwards. I'm happy to talk about it. And have a good day, everyone.
Thanks, Alistair. All right, so that concludes our lightning talks. We're going to take a 10-minute break, and that's not a joke.